In the last couple videos, we talked about how to define a function, what a function is, and how to determine if some relation is a function. Today, we're going to be talking a little bit about function notation and how to evaluate functions. So here, in this first example, we see the function f of x is equal to negative 3x plus 2. Okay, so I want to do a quick breakdown of what this is here. So we have the function f of x is equal to negative 3x plus 2. We say the function is f. The function is defined. We just say this is function. We just call this function f. Okay, and we say x here is the input for the function. Okay, and you can plug in anything in the domain of the function to this input here, this input x. Okay, and whatever you plug in here for x, you're going to plug in for any instance of x you see in this side of the equal sign over here. Okay, so for this one, we have f of x is equal to negative 3x plus 2, and we're asked to find f of 2. So if we say we want to find f of 2, we would say f of 2 equal to negative 3 times 2 plus 2. Okay, so really all we're doing is anywhere we see x in the expression on the right hand side over here, we're going to plug in 2. Okay, so we have negative 3 times 2 is negative 6 plus 2, or negative 4. So we have that f of 2 is equal to negative 4. Okay, very simple. So this is a function where if we plugged in, really we could plug in almost any, or really any value for this particular function, any value from the number line, and we should be able to get some kind of output for it. Okay, let's look at this one. We have h of x is equal to 4x squared minus x. And we're asked to find h of negative 4. Okay, so here we have 4 times negative 4 squared minus negative 4. You notice here how we plugged in negative 4 in every instance of x that we find. Okay, so let's do negative 4 squared first. Negative 4 squared is negative 4 times negative 4. So we have a positive 16. Okay, so we'll have 4 times 16, right? And minus a negative 4, that's the same as plus 4. Okay, so now we do 4 times 16, which is 64, plus 4, and we get 68. 68. Okay, so h of negative 4 is equal to 68. Let's look at this one. Here we have q of x is equal to 3x to the third minus x. And now we want to find q of negative 2. So let's plug in negative 2 for every instance of x we see. So we have 3 times negative 2 cubed minus a negative 2. This is the same as negative 2 times negative 2 times negative 2. So we'll have negative 2 times negative 2 is positive 4 times negative 2 again is negative 8. So this is 3 times negative 8. We'll have plus 2. All right? And this is equal to negative 24 plus 2, or we just have negative 22. Okay. How about this one? How about the situation where we have a of x equal to the square root of negative 2x plus 3, and we're asked to find a of negative 3. Well, a of negative 3, it's the exact same concept here. Anytime we see x, we're going to plug in the value we're asked to input. So we'll have negative 2 times negative 3 plus 3, which is equal to, negative 2 times negative 3, that is positive 6 plus 3. So 6 plus 3 is equal to the square root of 9, which is just equal to 3. So a of negative 3 is 3. But something to note here, in some instances where you have functions, not all inputs are valid. Sometimes there are restrictions on the domain. For example, if you were asked to find let's do this in a different color. If you were asked to find a of 2, what do you think would happen? Well, let's see. We have a of 2 is equal to the square root of negative 2 times 2 plus 3. Okay, so negative 2 times 2, that's negative 4. So the square root of negative 4 plus 3, which is equal to the square root of negative 1. Now, we're assuming in these functions that we're mapping real numbers to real numbers, so we don't have the complex numbers as our output. So we would say at the point 2, this function is undefined. Okay, and later on we're gonna be trying to find valid and invalid. We're gonna be trying to find the valid domains of functions. But just something to note: if you ever get something where you're not going to have a real number as the output, we're going to say the function is undefined unless you're asked to do otherwise. Okay, unless it specifically says you could use complex numbers as an output, we're going to say it's undefined. Okay, let's take a look at this one. We have g of x is equal to the absolute value of 12x minus 13. All right, so we have g is a g of negative 3/4. So we're going to plug in negative 3/4 wherever we see x. So this will be the absolute value of 12 times negative 3/4 minus 13. Okay, 12 times negative 3/4. All right, that is going to be the absolute value of negative 9. Okay, minus 13. We get that because 3/4 of 12 is 9, but it's negative, so we have negative 9 minus 13. Okay, and we know the absolute value of negative 9 is 9, so we have 9 minus 13. Okay, and we know that 9 minus 13 is negative 4. So g of negative 3/4 is negative 4. Okay, let's take a look at this one. Here we have h of x is equal to x over x squared plus 11. Okay. We want to find h of negative 2. Okay, so we'll plug in negative 2 and here we see x, so we'll have negative 2 over negative 2 squared plus 11. Okay, so we'll have negative 2 over 4 plus 11, which is equal to negative 2 over 15. And I think that's about as simple as you're going to make that. So h of negative 2 is negative 2 over 15. There's one other example I'm going to come up with real quick, just because I think it's probably worthy of note. Let's say we have p of x is equal to 3 over x minus 6. Okay, just like we looked at excluded values before, let's say you were asked to find p of 6. Okay, this would give us 3 over 6 minus 6, all right, which is 3 over 0. We can't do that, so we have to say that this is undefined. So if you see some kind of rational function, you have to be careful about possible undefined values. Okay, you're not going to be able to find necessarily. In our previous example, any real number should be fine, but in this example, there is a value that is undefined here, and that is x equals 6. Okay, so there are times where you've seen a couple of these now, where you will see you'll see functions that are not defined on all of the number line. Okay, there will be excluded values, or sometimes there will be many excluded values. So you do have to pay attention to that. You have to make sure that the input that you're given makes sense. If it doesn't make sense, then the function will be undefined.